This is 5.1 to 5.4 test review, starting with number 22. When we have a variable in the exponent of an expression and we are trying to solve the equation, what we need to do is isolate the exponential part of the expression. So we need to get rid of the subtraction of 3.1. We will add 3.1 to both sides. We get 2 to the negative 4x equals 31.1. Now that we have just the exponential part of the expression, we're going to add in a logarithmic function to both sides. And we're just going to do that by simply putting log of 2 to the negative 4x and putting in log of 31.1. So what that allows me to do is take this exponent and move it to the front of the problem. So I get negative 4x times log base 2, not base 2, log of 2. So negative 4x times log of 2 is equal to log of 31.1. Now, to get x by itself, I need to divide out the negative 4 and the log of 2. So when I divide by negative 4 and the log of 2, and I put that into my calculator, I will get x is equal to negative 1.2397. Okay, for number 23, I have an exponential function again, but my exponential part of this problem is just e to the a plus 7, and it does not include the negative 10. So I'm going to divide by negative 10, and I will get e to the a plus 7 equals 6.5. Now, because this is e, my logarithmic expression that I'm going to put in on both sides is ln, not log. So I want to leave myself some room here. So ln and ln. So now the a plus 7, that is my exponent, that is going to go out to the front. So a plus 7, because it's an actual expression with addition or subtraction in there, I'm going to put that in parentheses. And then I have ln of e equals ln of 6.5. ln of e is the value of 1, so I can cross that out right now. And to get a by itself, all I need to do is subtract 7. So a is equal to the natural log of 6.5, and then that value minus 7. So I will get negative 5. So a equals negative 5.1282. All right. Moving on down, looking at number 24, I have to solve that equation. Well, it looks like a mess. But I have to identify where my separations are. I have a minus right here, so that's a minus and a minus. So I have 3 terms here, and each of these 3 terms has a 10 to the x. So I'm going to factor out 10 to the x, and when I do that, if I cross all those out, I can see that I have x squared minus x minus 2, which is a basic quadratic. And this should actually be set equal to 0, otherwise there's nothing to solve here. So this is equal to 0. Now I have 2 factors, one of them being a quadratic, which I can factor out further. So if I factor this out, I will get x minus 2 times x plus 1, and you could do that by using quad 3. And now I'm going to set each factor equal to 0. So 10 to the x equals 0, x plus 1 equals 0, and x minus 2 equals 0. So here I will get x equal to negative 1. For x minus 2, I will get x equals 2. And for 10 to the x, if I follow my methods from above, I put a log on both sides, so log of 10 to the x equals log of 0. Um, the log of 0 is not valid. So right now I could already tell you that this is not going to work. But if I continue, I put my x out front, and then x times the log of 10 equals log of 0. Divide by your log of 10, and if you try to put that on your calculator, it will give you an error. So it will not work. So x equal -1 and x equal 2 are the solutions to that equation. Let's look at number 25. It's a word problem. It tells us about radioactive iodine. It is used by doctors as a tracer in diagnosing certain thyroid gland disorders. The type of iodine decays in such a way that the mass remaining after T days is given by the function m of t equals 13 times e to the negative 0.087 t, where m of t is measured in grams. So if we're trying to find the mass at t equals 0, all we're doing is plugging in t there. So we're trying to find the answer of 13 times e to the negative 0.087 times 0. And plugging that into my calculator, or knowing that I get a 0 up here in my exponent, and anything to the 0 power is 1, my final answer will be 13 grams. In part B, how much mass remains after 20 days? So my t value now is 20. So 13 times e to the negative 0.087 times 20. And I plug that in my calculator, and I will get 2.28 grams. So as you can see, it decayed, it got less. So in 20 days, it went from 13 grams down to 2.28 grams. All right, let's look at number 26. Talks about the age of ancient artifacts and the amount of radioactive carbon-14 remaining. So we follow this formula. A equals negative 8,267 times the natural log of d over d sub 0. They want us to find the age of an object if the amount of d of carbon-14 that remains in the object is 73% of the original. So all we're doing is replacing this fraction right here by the decimal 0.73, because that's 73%. And when you talk about D0 is the original amount, when you divide the partial amount that represents the 73% by the original amount, it will come out to be 0.73. So we don't need to worry about how much the actual original amount is. All we need to do is plug in 0.73 in place of that ratio. So we'll get negative 8,267 times the natural log. Let me write that off. Okay, 267 times the natural log of 0.73. And when I do that, I will get 2,601.7 years. That's how old this item is based on scientific formulas. Okay, looking at number 27, the magnitude of a star. Okay, the brightness or the magnitude is based on m equals negative 2.5 times the log of b over b sub 0. B is the actual brightness of the star, and b0 is a constant. So to expand the right-hand side, we're going to take and have m equals that negative 2.5 and we're going to have that being multiplied, and then we're going to divide or split this up into two logarithmic expressions. So that's in parentheses, log of b, because it's division, I'm subtracting log of b sub 0. Use part A to show that the brighter a star, the less its magnitude. So I'm just going to say b sub 0. Since it's a constant, I'm just going to give it a value of 5. The brighter a star, so if I say that the brightness is 10, I take that negative 2.5 times log of 10 minus log of 5. And I'm going to compare that to a brighter star. And let's say the brightness is 100 instead of 10. And my b sub 0 stays 5 because it's a constant. So I'm going to plug both these in my calculator, and I will get my answer to see and compare. And for the first one, for the brightness of 10, I get negative 0.75 for my magnitude. And for the second one, with a brightness of 100, my magnitude is negative 3.25. So you can see my negative value is higher or smaller value and then negative 0.75. So therefore, the brighter the star, the less the magnitude. All right, in part C, I don't really know how to say that, but I'll try. Betelgeuse or something like that is about 100 times brighter than Albearo. Use part A to show that Betelgeuse is 5 magnitudes less than Albearo. So if I have, um, I'm just going to put B and A. I'm going to set those up, and I'll have negative 2.5. And if I say Albearo is, let's say that 10, so we'll use log 10 minus the log 5. Okay, 5 or 100 times brighter would be 1,000. So I'm going to have log of 1,000 minus log 5, and I'm going to compare those and see what happens. And for Betelgeuse, however you say that, I got negative 5.75, and for Alberto, we get the magnitude of 0.75 negative, and you can see that is a difference of negative 5, so it is 5 magnitudes less than Albearo. Okay? And now, looking at number 28, if Mike wants to invest in a savings certificate that bears an interest rate of 9.75% per year, compounded semi-annually, how many years should he keep his investment to save $5,000? Okay, let me erase this down here, give myself some room. And I need to follow the formula A of t equals p times 1 plus r over n to the n t. P is my 5,000, no, 4,000. So I'm taking 4,000 times 1 plus my rate, which is 0.0975 as a decimal. N is my number of times compounded annually. Semi-annually means twice. and then I put n up here again, so 2. I don't know how many years it's going to be, but I want to save $5,000, so I have a total of 9,000. So this is going to be 9,000 equals all of this, and I need to find my t value. And to do that, I'm going to have to isolate the exponential value and do the logarithm both sides. So first, I'm going to start off by dividing by 4,000. Okay, and I get 9/4 when I simplify that all the way down, equals 1 plus 0.095 over 2 to the 2t. So now I'm going to do the log of both sides. So log over here and log over here. So I get log of 9/4 is equal to log of 1 plus 0.0975 over 2 to the 2t. That 2t can go out to the front. So log of 9 over 4 equals 2t times log of 1 plus 0.0975 over 2. And I'm going to be dividing out the 2 and the log of 1 plus 0.0975 over 2 on both sides. Okay, so my final answer that I'm going to be putting in my calculator is going to be log of 9/4 divided by 2 times the log of 1 plus 0.0975 over 2 and get my answer. 8.52 years. So it's going to take about 8.5 years to double to earn $5,000 of interest. Okay? And that's it.